right, so there's one other thing I want to show you. It turns out that if x is distributed binomial with parameters n and p, then x can be expressed as, or it's equal in distribution to, the sum of a bunch of Bernoulli random variables. Okay, this can be really useful. So I told you that these binomials can be that these Bernoulli random variables can be thought of as building blocks for other random variables. And here's a good way to see that for the first time. Okay, so if each one of these guys is 0 or 1, right? So let's say if you think back about the multiple choice quiz example where you're guessing blindly at each of 10 questions and each question has 5 possible answer choices, then maybe y sub k are Bernoulli with parameter p, okay, and they're all independent. Then and that's important too. These are independent. Okay. Then so each one of these is going to be a 1 if there's success, or 0 if there's failure, right? So the number of successes, the total number of successes in trials is just going to be the sum of the 1s and 0s, right? So that's a really useful way to think about this. And guess what? It also gives us a quick way to write down the expected value of x, right? The expected value of x is then going to be the expected value of that summation, right? But I already know from a previous theorem that the sum, the expected value of the sum is the sum of the expected values, right? And what's the expected value of a Bernoulli? P? It's just P, right? Now I'm going to sum up n P's. And what is that? NP, right? That's what multiplication means, okay? And multiplication is just a shortcut for addition, all right? Hey, that's a lot quicker than all that other stuff we did. What's the variance of x? Well, this will be the variance of the sum of these guys. K equals 1 to n. Now, we haven't proved this yet, but it turns out that if the yk are mutually independent, then you can take this step. If these are independent, then the variance of the sum is the sum of the variances. It's not true in general, okay? Not true in general. We'll talk about that later. Haven't gotten to this step, but I'm going to do it anyway. What's the variance of a, I've got n of these things, so I'm just going to multiply by n. What's the variance of 1 Bernoulli? It's p times 1 minus p. Hey, that's exactly what we got up here. Same thing. But this is a one-liner, and one-liners are hilarious.